ऑलराइट गाइस, तो आज हमारे पास एक क्वेश्चन है स्लाइडिंग विंडो अप्रोच के लिए। ठीक है, क्वेश्चन ये है कि वी आर गिवन एन एरे एंड अ टारगेट। ठीक है, नाउ वी हैव टू find a sum of any sub array whose sum should be smaller than equals to 5. Okay, the maximum the sum, the better it is, but it should be smaller than equals to 5. Okay, so the first approach will be of going to each and every element. Okay, and then finding all subarray with respect to that element, with respect to that element. So let's say my I is 0 starting and j is also 0. Okay, so we will have two nested for loops. Okay, when I is 0, j will be 0 1 2 3 4 5. Then again when I equals to 1, j is equals to 1 2 3 4 5. Then let me just write it down. Okay, so let me tell you how it's gonna look like. For 0 we're gonna traverse 0 1 2 3 4. Okay, for 1 we're gonna traverse through 1 2 3 oops and 4. For 2 we're gonna traverse 2 3 4, and for each traversal, okay, we're gonna add the value and we're gonna check if it is smaller than equals to 5. Okay, then we will make it a max value, and then we have to return that max value. Okay, we always have to keep in mind that this max value should not be greater than 5. It should always be smaller than equals to 5. Okay, so if we do this nested approach, okay, this will give us on square. Okay, that is the problem. This will give us on square. And sometimes if you write unoptimized code, it can also give you on cube complexity. Okay, which is very bad, because if we have an array length which is 10 to raised to the power 5, the question will not be able to, we won't be able to solve this using on square. The computer will run a TLE. Okay, so an optimum solution I want to discuss about is sliding window technique. Uh, Now what we're gonna do in this is that uh, we first will have a index called 0. Okay, and then we're gonna have a sum. Okay, we're gonna add all the add all values till our sum is uh, greater than equals to target. Okay, so let's say I start from 0. In 0 I have 2, so 2, then I'll go to 1. 2 plus 1 equals to 3. It is still not it is not still greater than equals to target. Our target is 5. Okay, target is 5. Now we're gonna add the index 2, which is 5. So again 3 plus 5 will become 8. Okay, will become 8. Now 8 is greater than equals to 5. It is greater than equals to 5. Now what we're gonna do is we're gonna start subtracting the value from the 0th index. Okay, so till second index we have our value, we have value 8. Okay, which is greater than equals to 5. What we're gonna do is we're gonna start from we're gonna take index j, which will be 0, and we're gonna start subtracting the values. Okay, until until our value again becomes smaller than target. We're gonna do this. Okay. So the first value is 2. So we're gonna say 8 minus 2 equals to 6. It is greater than 5. So we're gonna say, and 6 is not equals to 5. Okay, so we cannot store in any kind of max value which we have to return. Okay, it is still 0. Now 6 minus 1, if you see, if you do 6 minus 1, sorry, the 1, okay, here it will become 5. Here you can say our max is 5. We have found the maximum value. Okay, so the subarray will become index 2. Index 2 is giving us this max value. Now we don't have to consider any kind of subarray for this. All we need is just a value. So we got the value, then we will break our code, because see, if we got, if we have, if we would have got 4, okay, then we would continue for the problem, because the max we can achieve is 5. So there could be a possibility if we go ahead we can achieve 5, but here we have already got 5. So we will just simply break the loop and we will return the max value. So here your time complexity will be on only. Okay, okay, because you have started from 0, you have stopped at uh, index 2, and then you have created one another index j, and then from j you have again started subtracting the value. Now if we would not have gotten 5, we would have said that let's say the target is 6. Okay, let's say the target is 6. If t is 6, or I can say 7, okay, if t is 7, then I would say that 5 has become sorry, 6 has become lesser than 7. Okay, in this case. So in this case our j is 1. Okay, so now what I would have done is that I would have again started I from 2 and j from 1, and I would have started adding or more elements. So our value is 6. So 6 plus array I equals to 6 plus array I, array 3, which will be 3, it will become 9. Okay, now again 9 is greater than target, which is 7. Okay, which is 7. So again we will start subtracting 9 minus j, and j is 1, so 1 is obviously 1, we will get 8. So we will again minus j, which is 2, and 2 is 5. 2 is 5. So 8 minus 5 has become 3. Okay, now again we will stop. Here I will be equals to uh, 3. I is equals to 3 and j is equals to 2. Okay, and we will keep on repeating this process until we find the max value. So max value could be anything, but it will be lesser than equals to the target. Okay, uh yeah guys, so that was the solution, that was the on solution. I hope you got the solution. I tried to make it as clear as possible, and this technique is called as sliding window, because we are taking a group of values first, then we are performing some operations on it, and again we are forwarding that group to the next elements so that we can recalculate the value. So yeah,